Hi everyone, hope you're doing well today. This is Physical Science Unit 7, Lesson 1. And we did leave off last time we were at school in Unit 7, so I wanted to spend some time just going back this week and next week with reviewing this unit. So the sites we're going to use in Physical Science, again, will be Think Central, the digital lesson, and the text. Today I'll play that for you. As we look at Lesson 1, I'll use Jefferson Lab again for review questions. BrainPop can also be, will be used, as will Pass, various clips with questions to follow. Perhaps I'll try even virtual labs and more. So again, this is a work in progress. So thank you for your patience. Unit 7, Work, Energy, and Machines. And so where we left off, we had gotten through, I think, Lesson 1, but for today I wanted to make sure that we review this unit. So Lesson 1 is Work, Energy, and Power, which we'll go over today. The next lesson you'll have will be Lesson 2, Kinetic and Potential Energy, and then Lesson 3, Machines. So I sent worksheets again for your packet for Lesson 3 in the first packet. So again, there's some overlap going back and forth too with review, so thank you for your patience. And you should be receiving in the mail, hopefully today, if not tomorrow, a packet of work I put together for all of the classes. And so if your parents have any questions, they can email me, I can call them back, or I can email a question back. All right, so let's take a look at Think Central right now. I'm going to show you Unit 1, Lesson 1. I'm going to play for you, I'm going to have you listen and watch pages 428, 430, and 431.
Work it out. What is work? What comes to mind when you think of work? Most people say they are working when they do anything that requires a physical or mental effort. But in physical science, work is the use of force to move an object some distance in the direction of the force. In scientific terms, you do work only when you exert a force on an object and move it. If you want to do work, you have to use force to move something. Work is done only by the part of the force that is in the same direction as the motion. Imagine that you pull a sled through the snow. You pull the rope up at an angle while you pull the sled forward. Only the part of your force pulling the sled forward is doing work. The upward part of your force is not doing work because the sled is not moving upward. Active reading. 5. Summarize. How does the scientific definition of work differ from the familiar definition? How is work calculated? Work is a measure of how much force is applied to move an object through a certain distance. You can calculate the work a force does if you know the size of the force applied to an object and the distance through which the force acts. The distance involved is the distance the object moved. You can calculate work using the following formula. Work equals force times distance. W equals F times D. Force can be expressed in newtons, and distance can be expressed in meters. When you multiply a force in newtons by a distance in meters, the product is a unit called the Newton meter, N times M, or the joule. The joule, J, is the standard unit used to express work. 1 joule of work is done when a force of 1 Newton moves an object 1 meter. To get an idea of how much a joule of work is, lift an apple, which weighs about 1 Newton, from your foot to your waist, about 1 meter. Most of the Energizing. How are work and energy related? Active reading. 7. Identify. As you read this page and the next, underline examples of energy provided in the text. It's important to conserve energy, your teacher might say, as she turns off the classroom lights when everyone leaves. I'm all out of energy, you might say, when you just ran outside for a long time. What does the word energy actually mean, and what does it have to do with work? Energy is the ability to do work. You might think of energy as the ability to cause a change. But now that you know more about work, you can learn more about energy. Energy is the ability to do work. This means that energy is the ability to apply force to cause movement in the direction of the force. For example, when a dog pulls a sled, the dog is using energy. When you do work by swinging a tennis racket and hitting a ball, you are using energy. The work done by energy doesn't have to be visible, however. For example, when energy is transferred to an object in the form of heat, the particles in the object move faster even though the object itself does not move. Work and energy are so related that they are both expressed in the same unit, the joule. You can think of work as a transfer of energy. In fact, energy is transferred every time work is done. Work transfers energy. When a person does work on an object, he or she can transfer energy to that object. For example, you may know that wind turbines are a way to produce clean and renewable energy. But how is work involved? The wind does work moving the blades so that they spin. The wind has the capacity to do this work because of the energy of its motion. Inside the turbines, more energy transfers occur so that the energy of the blades is transformed into electrical energy that can be used at home. A carnival game can be an example of work transferring energy. The goal of the game is to hit a target with a ball. You do work on the ball as you throw with your arm. When you change the position and speed of the ball, you transfer energy to the ball. The ball then does work on the target, and you win a prize. Visualize it. 9. Synthesize. The wind does work on the wind turbines below. Describe how the work is done.
Okay, so as you see, there are questions that they're asking you, and since you don't have access to your book, obviously just do your best with, you can answer the question out loud if you want to, but you won't have the capability of underlying. So I'm going to have you complete a couple of different activities online today. So let's take a look at Brain Pop. And so I'm going to ask you after this lesson to log into brainpop.com, and the login for everyone, your username is HYounger and the password is Rivermont1. And so let's take a look, and then when you get to that site, I'm going to ask you to type in wind energy. So when you look at, again, BrainPop, go ahead and sign in or log in. We get the login. And type in HYounger, and Rivermont1 is the password. And then once you log in, go ahead and type in wind energy. And if you've been familiar with BrainPop before, you can click on the small video. I'll ask you at the end of this lesson to take the quiz, and then there's other parts of this that you can review. It has been a while since I've had BrainPop, so this is a new site for me. Usually I'll be able to link into sites that they allow for free, but now the whole site is for free, which is great. So let's go ahead and watch this clip, this 3-minute clip on wind energy.
Dear Tim and Moby, how is wind used to make energy? From Annika. Well, that's a good question. First, some history. It may seem strange to think of wind as a source of energy, but we've been harnessing it for thousands of years. In ancient Egypt, people used wind to power their sailboats along the Nile River. The first windmills were used in Persia, in today's Middle East region, about 1500 years ago. Primitive windmills look sort of like egg beaters, and they were mainly used for grinding grain and drawing water from wells. Later, people in Western Europe improved on the technology by making propeller-style blades out of sails. Today, modern wind turbines are strong, sleek, and well suited for converting the force of wind into energy. Well, the rotor blades are aerodynamically shaped to make them really efficient. The blades convert the wind's energy into a rotational energy called torque. How much torque is produced depends on three things: air density, wind speed, and the length of the rotor blades. As each of these factors increases, so does the amount of power produced. When strong winds blow against a turbine, the force causes the rotors to turn pretty quickly. Inside the turbine, a generator converts the movement into electricity. That electricity can be sent through power lines to light up your house. Actually, there are lots of places where you can see wind turbines at work, but one of the most dramatic is called a wind farm. No, they don't grow wind in a wind farm, but it's a place where electricity is made from wind. Wind farms typically have at least a couple dozen turbines that are positioned to take advantage of local wind patterns. Good point. Many people think it's a good idea to invest in renewable energy sources like wind, which is clean and relatively cheap to generate. A renewable energy source is a source of energy that, for all practical purposes, never runs out, like wind or solar energy. That's in contrast to fossil fuels like coal and oil, which the Earth only has finite amounts of. Right now, only about 1% of all the power we use in America is created by wind. Even so, the United States is the second highest producer of wind energy in the world. And since North America has more sites suitable for wind farms than any other continent, our wind power output should have no problem growing. Yeah, there are a few drawbacks to getting electricity from wind. For one thing, some people think turbines are ugly and they don't want to look at them all day. Other people worry that wind turbines are dangerous to flying animals like birds and bats. Some studies suggest that the number of animals hurt by wind turbines is fairly small. But it is a real problem that the wind energy industry is looking into. No, it's windy out here, but not that windy.
Okay, so when you're finished with this lesson, you can go back through this website and to take the quiz. And since the login is under my name, it's not being saved or graded, so you could just do the review option. You could check out the graded lesson if you want to, but I don't think it's keeping track with me since it's using my login. So when you look at this site, again, hopefully we'll find things that you find interesting. All right, and so going back to our PowerPoint, and I hope I wasn't being confusing because again, this is a new site for me too. So when you take the quiz, you could try the quiz as review or graded. I think my point being, I'm not sure that it's not going to personally save your information, but the grading could be giving you a grade. So I'll look into more of that too when I post it next time. So think outside the box. So the last page that I showed you on Think Central said, imagine you work for a wind turbine company. Your company would like to provide tours of the wind farms to students and tourists. Make an advertising brochure that explains what wind turbines do and why people might be interested in learning more about them. So if you have an extra piece of paper or spare paper, this could be an activity that you could do after this pre-recorded Zoom. All right, let me show you a clip also if you would like more information about wind turbines.
is a powerful source of energy on our planet. In fact, many of us have seen it in action, propelling sailboats across open seas or turning the blades of a farm's windmill to grind grain or pump water. Modern wind turbines are basically sleeker, higher-tech versions of the windmills of the past. But instead of using the wind to do farm work, they're designed to convert wind energy into electricity. Here's how it works. Wind blowing across a turbine's blade creates more pressure on one side of the blade than the other. This causes the mechanism of all three connected blades to turn. This rotation pushes on a series of spinning parts inside the body of the turbine, which in turn spins a generator, producing electricity. Because wind is always blowing somewhere across the surface of the Earth, it's considered a renewable resource. And because the only thing required to turn a wind turbine is moving air, wind farms emit no greenhouse gases. However, even though it's clean and abundant, there are a number of reasons we still don't use wind power more widely. The first, and perhaps most important, is that the wind doesn't always blow, at least not always in the same spot, and technologies for storing lots of electricity for later use are currently very expensive. Another problem is location. It doesn't make sense to put wind farms just anywhere. The best sites are open, windy places, which are often far from city centers where energy demand is greatest. So long transmission lines are necessary to move the electricity to where it's needed. Finally, while wind farms are relatively cheap to operate, they cost a lot to build, especially in comparison to existing coal and natural gas power plants. The result is that many wind projects simply never get off the ground. At the moment, wind power makes up only a small portion of the electricity produced in America, but it's a rapidly growing industry that many experts believe could one day slash fossil fuel consumption. And just like solar, it will become cheaper and easier to use if we can find better ways to store the electrical energy it generates.
Okay, let's go back to the PowerPoint. And so an activity that you can do after you look at this lesson, again, is to make an advertising brochure, imagining again that you're working for a wind turbine company, and you would like to provide tours of the wind farms to students and tourists. And so make an advertising brochure that explains what wind turbines do and why people might be interested in learning more about them. And going back to the brain pop, I will tell you that I just did take a minute to look at the quiz. You can take the quiz on brain pop either by review. If you have it graded, you can email me your results. You don't have to do that this time. So in future lessons, I might have you send me or email me your results just so that I can see that you're on brain pop. But again, if you have any questions, please email me. Again, this is a learning for me as well. All right, so let's take a look now at back to the student text. I'm going to show you two more pages, pages 432 and 433.
Superpower. What is power? The word power has different common meanings. It is used to mean a source of energy, as in a power plant, or strength, as in a powerful engine. When you talk about a powerful swimmer, for example, you would probably say that the swimmer is very strong or very fast. However, if you use the scientific definition of power, you would instead say that a powerful swimmer is one who does the work of moving herself through the water in a short time. Power is the rate at which work is done. For example, when two cranes lift the same crate the same height, they do the same amount of work. The one that lifts the crate the fastest is the more powerful crane. Because work is also a measure of energy transfer, you can also think of power as the rate at which energy is converted from one form to another. How is power calculated? Because power is a measure of how much energy is transferred in a given time, power can be calculated from energy and time. Sometimes you know that energy is being transferred, but you cannot directly measure the work being done. For example, you know that a TV uses energy, but there is no way to measure all of the work that every part of the TV does. To calculate the TV's power, divide the amount of energy used by the time it is used. Power equals energy divided by time. P equals E divided by T. Remember that energy is expressed in joules, so power is often expressed in joules per second. 1 joule of energy transferred in 1 second is equal to 1 watt, W. The watt is the unit of measurement for power. You have probably heard the term watt used in connection with light bulbs. A 60-watt light bulb requires 60 joules of energy every second to shine at its rated brightness.
All right, let's go ahead and look at some of the review questions. So what I'm going to do is I'm going to play these questions or show you these questions, and I'll just have you answer out loud, or to yourself. And these are coming from the visual summary at the end of the chapter. Work is the use of force to move an object a distance. Work is force multiplied by. Work is done only by the part of the force that acts as the motion of an object. So again, as we're moving forward doing this, you're just answering these to yourself. And so the answer is in red. Work is the force multiplied by distance. Work is done only by the part of the force that acts in the same direction as the motion of an object. Energy is the ability to do work. What transfers energy? Work transfers energy. Power is the rate at which energy is transferred. Power is blank divided by time. Power is typically expressed in blank. And the answer, power is energy or work divided by time. Power is typically expressed in watts. So I'm going to have you do now also, I have a number of activities. I'm doing science every other week for this reason, because I am giving you a lot of different activities to do or trying to. So if you go on solpass.org, again, go Rivermont Roanoke, type in, and then Bulldogs is our password. Please review number 10 under physical science, where it says work, force, and motion, and you can review the study guide and activities. Also, you can go back to BrainPop to complete the review and other activities presented in Wind Energy site. And again, to clarify, when you're doing the quiz, you can either look at the review or the graded part of it, but I'm not requiring you right now to email me those answers. All right, our next lesson is going to be kinetic and potential energy. I hope that you all have a great day, and I will be seeing you soon.